All right, good morning, everyone. Today, I'm going to do a specific session on how do you now you know how to create machine learning models. So we have looked at linear regression. So now we'll try to see how we can use a model, right, a machine learning model, uh, and probably try to reuse it. So now the whole purpose of developing machine learning modules or models is to use it to predict. So if you want to do it, so you have to understand, if you try to do it on the go, so it might take a bit of a time, and also it might not give you the needed results. So if you look at a normal machine learning pipeline, what you basically do is you'll have a data set, right? So whether it's supervised or unsupervised, even reinforcement learning, you have a sort of a data set, right? So you'll have data, and you'll be using the data, right, uh, to train, right, uh, train and of course validate, and then thereafter uh, test your data or test your predictions, right? So this is like normally what happens. So you have 60 20 20 sort of like model under training, validation, testing. So this is what you do. So when you have more the data, so the bigger your data amount, your testing results will be better. But there's a small catch here that what if all the time when you want to do testing prediction, you want to load your data and then to train it, so it might take a time. So in the real-time situation, it's not probably a good idea to always train your data. So there is a solution for this. So one solution is, this is your model, like when you get everything here, this is your model, right? So this is basically your model. So what you can do is, like normally do in computers, you can basically save your model, right? So a machine learning model also can be saved, right? So if you can save it in a database, right, or whatsoever, so once you need it, you can use it. So that's the idea. So save your model, right? So save your model, and once you want it, you can use it by loading to the memory. So that's sort of the logic behind uh, this exercise, right? So so we'll see how you can, once you build a model, how you can load, yeah, so how you can save and load a module. So to do this, basically there's an approach called object serialization, right? So the approach is called object serialization, right? Serialization, object serialization. So uh, so the definition is, in object serialization, your machine learning model, so your model will be converted to a stream of bytes. So to a stream of bytes. So once you really open your model, once you save this, you don't find the meaning in it because stream of bytes. The purpose of putting it to a stream of bytes is to either to save in the disk, right? So the save in the disk, uh, or else you can probably transfer on a network. So it's easier once you have it, transfer in the network, or else you can save it into a same thing again, into a database. So you can have it in a morphological format. All right. So this is what you do by saying serialization. So this is called serialization. Okay, serialization. And then of course, once you do this process, you will find everything here in this particular format. And of course, when you want to reuse it, you have to convert it back, right, to the original format. So this is called deserialization. So of course, the reverse process of this deserialization. So once you have that deserialization, you can of course use it for the prediction. All right, so that is the idea. So there are a few approaches to do this, right? The first approach is using a library called Pickle, right? So there's several ways to do this, but Pickle is the more famous way of doing it. So Pickle library, Python, you can get the Pickle library, and also there is another library which will be different called Joblib, right? Joblib. So this is also similar to the pickle approach. We'll do this exercise, pickle approach, but when you look at the differences, it clearly explains that when you have a large data sets with say numpy arrays, that's what they say, right? Numpy arrays, so better to use Joblib. So probably performance-wise, Joblib is better when you have large amount of data, or maybe even you can use pickle. So there are two approaches, and the third one uh, uh, is to use more of a manual method uh, to use JSON. So I have tried the previous two methods, but we see if you have time to go to this JSON method also. I guess you guys are more familiar with this more like JSON like type of technology. So we try to see whether we can work it out. I'm not really sure, but these two, of course, we can try implementing. So, so this is basically what I'm going to cover now. It's recording. Sure. Right. So now what we'll do, yes, I think that's all about the theory part. So those approaches can be used. Okay, so try to understand there's a lot of like practical limitations of this way also, but it's quite important to use this because it will give you reusability. No? It will give you reusability. So first, I'll try to do a simple exercise which you all have done earlier. We all have done. So I'll open PyCharm. So I'll create a Python file, and I will name it as saved with pickle .py. All right. Okay, and okay, so the basic stuff. So I'm going to import pandas std. So every time, rather than copying your code, so start. I mean, like, try to write your code. So that will make sure that you won't be forgetting the important parts of the code, right? So I'm going to use the linear model again. So that part is done. So then what I'm going to do, I'm going to use right. I'll use the same okay, I'm going to use the same home prices. I think I have the file, yeah, home prices CSV file. That'll be easy to work with. So I'm going to say df and pp read CSV, and I'm going to load the home prices CSV. Oops. Okay, that's done. Then I can print the head to make sure that everything is fine. So let me run. Alright, so I have the data all fine. So now I won't be explaining anything because we have done this several times. So next is to use the linear model, linear regression. So I'm going to use linear regression, and okay, and then I'm going to pass the data. So I want to, okay, so that's the area. So it's only have area, you can remember. Yeah, so that should go in. Oops. And what else? So I think we need the price. Right, so that's the dependent variable. Okay, no need of spaces. Here a space. No. Everything looks fine. So okay. So then I'm going to get the coefficient, and I need the intercept. Okay. And what else I need? Okay, I can do a basic prediction. Model predict. Okay. So I'm going to predict it for 5,000. Right. So I will check the answer. Okay. Okay, I have to print this. So I'm not going to print other things. So now you know the drill. Okay, so we'll check. So the whole purpose now is to, okay, I'm getting 85,000 something. Okay, 85,954. All right, so that's what I want. Right, now what I'm going to do, now I have a trained model. So now hereafter, now to save the model as a serialized object or serialized object, first using Pickle. Okay. So I need to import Pickle at this particular moment. So I'm not sure whether I have installed Pickle into my environment. Seems to unused imports. Yeah, that's right. Okay, so maybe Pickle is there. So what I'm going to do now, I'm going to open a model. So first the parameter is the model. My saved model, my saved MD Pickle. Right? Okay, then I'm going to write it. So the second parameter is to say whether I'm going to write it as a binary. So I'm going to say write it as a binary, right? And as a file. So that will do the trick. And then I'm going to dump Pickle dump, and so the model. So that's a model object. So dump the model object to the file. So this is the model object, all right, and this is the file. So I'm going to dump the model object to the file, right? Okay, that is done. So now I don't have any model object file here, right, in my directory. Let me check. I'm going to run this. Okay, and you see I'm getting this my saved MD Pickle file. Okay, alright, so I get the file. Here is the file. So all fine. So I'm going to open this. I don't think you can open it because it's a binary, right? Okay, I'll open it to text, and I would see some gibberish. So obviously because it's a binary, so I won't be able to understand. So there's no need to worry too much about this because I have saved my model. So now we will load the save model, right? Okay, so that this is interesting. Now what I'm going to do, please concern on this previous predicted value for 5,000, right? So just check this one, right? So I'm going to do the same prediction with the loaded now loaded model, not loaded save model. So I'm going to use the same, so same here. So no difference. I'm going to copy this one. There's a small difference. Only thing is I'm going to read this, right? So I'm going to say read, then not dump, right? So I'm going to load this, right? So again, this time it's basically the file, so I don't need to um, yeah, load it to a model or something. So whatever the return of this would be new, sorry, a loaded model. Okay, that would do. So let me run to check if is there any problem. Okay, no problems, right? So now what I should do, there should be a here, loaded, okay, that would be. Right, now I'm going to use the loaded model, right, and check the coefficient. Okay, and I'm going to print this loaded model and intercept. Okay, intercept. All right, now to the important part, okay, which is to check the prediction. Okay, now predict, right? So previous one, see, let's check the previous one. I'm going to do the same thing here. 1, 2, 5,000, and this should get printed again. So I can double check whether it's the same prediction that it gives for 5,000, area for 5,000. If it the same value like here, so I'm happy with my same one. Let's see. Okay. Hold on. Intercept. Okay, intercept. Okay, that would do. Spelling mistake. Okay, predict. Okay, predict. Oops, my bad. Yeah, same exact result. So now I know this worked. Right? So it worked. No problem at all. Right. So now I'll use a second approach, which is the Joblib approach. Right? Joblib approach. So to do that, it's almost the same. Now we'll try the same with Joblib. Okay, Joblib. So you can use whatever convenient to you. So, but only thing that they're saying, Joblib can be better in terms of having large arrays, especially NumPy arrays in your data set. So that's the logic that they did. So for this, I want to import Joblib. So we'll do it here from sklearn externals, externals import Joblib. Alright, we have it. Okay, so that's part of the sklearn library. So that's why it's imported like this. Actually, right now use Joblib. So things would be similar as in the previous case. So Joblib dot we have to use the dump. Okay, and then model is our previous model, and this time my saved. So this time also same, right? Model using Joblib. Previous was Pickle. Now this is Joblib. Okay, so let me check. So here you should get alright, so fine. So my saved MD Joblib, that's also there. So now what to do? Now we load and test this. Okay, so Joblib, very similar in the case of Pickle. So my save Joblib. Alright. You can try out getting the Pickle binary file. Don't think it will work. I haven't tried, but you can test it. Then I can give a name. I used whatever, right? Whatever. That's fine. So that will be the uh, loaded model. Now I'm going to check the intercepts and coefficients. I'm just directly going to test with uh, whatever predict. Okay, okay, predict. Oops, sorry, 5,000. That's cool. Then I'm going to print. So if everything is fine, should have another print here, which should be the same. Okay, wait guys, so we'll see whether we have done it right. Alright, cool. So everything seems to be good. Okay, everything seems to be good. So that's saved with Pickle, and so this should be saved with Joblib as well. And this one I have not tried out, which is using JSON. Let's see. Let's see. I'm not sure this will work out. We see. Can be fun even if it doesn't work. Okay. So let's see. Mm, 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 Okay. So basically, you should have this script up and running. All right. So what is important for this is okay. I think we need to have JSON with us. I'll do import it here. I don't want to go up now. Okay, import JSON, and also I might need NumPy also. NumPy. Okay, I have already imported NumPy, so that's good. Mm, yeah, not using it. That's that's all right. That's all right. So so now what we should do? Uh, we can do it in different ways. When I looked into a tutorial, okay, so what I'll do, hold on guys. Okay, so yes, so they have a approach where they have building up a class. So I'm going to do that. My reg, right, so it's logging of this. So of course you have to use logistic regression. Hold on. So that could be okay. Let's see. I'm going to use the linear model. Yeah. So that's I believe the way to go ahead. Yeah. So that's I use for linear regression. It's okay. So that's fine. And then okay, just give me a second. I will try to import this statement and see whether it's working. Rather than wasting your time, I'll do it that way. All right, guys. So I tried it a bit. There are some issues coming. So what I'll do is I will not try to worry too much about the JSON method right now. So, but I'll try to give it as a homework for you guys. So that's the easy way out. So please try it out and let me know like what have you learned, right? So and probably the next time we'll meet with that one. All right, so please try to do this by your own, and yeah, so happy learning.